Hello and welcome to Connection of the Month, the series where we take you inside the HSS Connections Hub. I'm Ted Goldstein, structural engineer with Atlas Tube, and this month we're going to be looking at a Shuriken HSS Splice. So Shuriken is a device that's come up in a number of our other videos. Basically, it allows us to make field bolted connections in cases where we'd normally have to weld things, and the HSS column splice is the original application that it was developed for. Let's jump right in. Okay, so here we have a very basic HSS column splice using Shuriken. And before we even jump into the specifics, I do want to highlight up here, you'll see that this is actually version 81 of the calculator. And just it goes to show, I mean, this has been around for less than a year, but we're constantly making updates and improvements, both in features to allow you more flexibility in designing the calculation, but also changes to make it more user-friendly, improve the explanations, that sort of thing. So if there's a feature that you don't see yet in this video, by the time you're watching it, there's a good chance we may have put it in there, and we're planning to continue to upgrade the capabilities of these calculators, not just this, but really all the connections. So with that, let's go ahead and put an image on the screen, just show what this connection would look like. If you could see the interior, basically we've got the Shuriken there that are going to be holding the nuts in place so that we can bolt this connection from the outside. So the configuration I have here to start off is basic gravity column splice. And basically, because it's a pure compression, really all the load is being transferred in bearing. And the plates and the bolts are just there to prevent the pieces from slipping off, keep them aligned with each other. That's simple enough. It's a very common occurrence, but we'd like to make this a little bit more interesting. So let's go ahead and add some seismic load into the calculation. I'm going to add some tension, if the frame is in uplift. And then also I'll put in some moment, 80 kip-feet of moment. And not surprisingly, when we do that, now we're way over our capacity. And intuitively, you wouldn't expect 2 bolts on each face to be adequate here. So the first thing I'm going to do is just go ahead and add some more bolts. Let's go from 1 row to 2 rows. And when we do that, the graphic updates immediately. It's always live. And we can see we're governing percentage is now 121%. So if we go down and look at the limit states that we need to adjust, we can see we have the bolt capacity and we have the plate capacity. And I'm actually going to look at the plate capacity first. So if we come here on the left, we can find the plate capacity section, and it's got all the different limit states that the plate that govern the plate strength, and of course every line of each calculation. And as with any connection in the connection hub, we can hit the line of the calculation. It'll give us an explanation and also a code reference. So in this case, tension yielding is okay, but tension rupture, we're at 121%. So essentially, the holes have taken out too much material from the plate, and we're failing in net section rupture. So this is not something we can fix by just adding more bolts, because it's really the width of the plate that's governing. So what we could do, we could make the plate thicker, of course, or in this case, I'm actually going to change the edge distances of the plate, and that will give us a little bit more meat to take that tension load. So if we go here to plate properties, we can drop down, and at plate horizontal edge distance, I'm going to go from 1.5 to 2.5. And again, the graphic, we can see we've got a bit of a wider plate there. And now that particular limit state, the plate capacity is down to 87%. So we're left only with the bolts. Now, there are a few things we could do here. One thing we might think to try is, well, let's use a bigger bolt. So let's see what happens if we switch to a 1-inch bolt. When we do that, we do solve the issue of our bolt capacity. We've gone from 121 to 93%. But now we've got a new problem. The HSS column capacity itself, the face of the column, is failing. We're at 108. So let's go to the left, right? Come over to the column capacity, and we can see that the issue is block shear. And there's not really a whole lot we can do about block shear in the column face, because of course we could use a thicker column, but short of changing the member size, there's not a whole lot we can do about that without adding additional rows of bolts. And indeed, that is an option. But in this case, what we're going to do, we're going to switch back to 7/8, which gets rid of the block shear problem. because the holes are smaller, so we have a little bit more meat to resist that force. And we can go to an A490 bolt. And when we do that, now we've got the bolts down to 96, the block shear in the column face is 98, and of course the plate capacity is still at 87. So this is an acceptable connection. Of course, if you, for example, let's say there were already some 7/8 inch A325s on the project and you didn't want people to get them confused, we could go to a 1-inch bolt. In fact, let's just give it a try. Go to a 1-inch bolt. Of course, now we have that issue with the block shear on the face of the column. And so you could add another row of bolts. Now, admittedly, if you're adding another row of bolts, you probably don't need the 1-inch size. So we can go back to our 7/8 A325, and indeed, we're at 81%. So as with so many connections, there are a lot of different ways to get where you need to go, often depending on things that are beyond just the math. We have a lot of ways, a lot of different levers that we can pull to make this connection work. So with that, this has been this month's Connection of the Month, and hope to see you next month.